Welcome to Study Loop.
In this problem, on the first law of thermodynamics, we are told that 3 moles of an ideal gas are taken around the cycle ACB as shown in the diagram. We are given the heat capacity at constant pressure, and we are told that process AC is at constant pressure, and process BA is at constant volume, and CB is adiabatic. Now, we are given the temperatures of the gas in each state and are asked to calculate the total work done in the cycle. So we first know that path AC has a constant pressure. And so for a constant pressure, we know the work done in this process WAC is equal to the specific pressure P times delta V, the change in volume, which we can write as the number of moles N times the gas constant R times the change in temperature delta T. And so this can be written as N times R times the temperature at state C minus the temperature at the initial state, which is state A. So we can substitute our values in here and we can calculate this work done. So this is 3 moles for N times the gas constant R, which is 8.3145, and that's joule per mole Kelvin, times the change in temperature of 492 Kelvin minus 300 Kelvin. So this gives us the first work for the process AC to be 4.789 times 10 to the 3 joules. So that's for process AC. Now let's look at process CB. We are told that CB is adiabatic. And so for an adiabatic process, the heat transfer Q is equal to 0. So the work done in this process, we'll call it WCB, is equal to the heat transfer Q minus the change in internal energy delta U. And since Q is 0, this is simply minus delta U. And we can write the change in internal energy as minus N times the heat capacity at constant volume for the gas times the change in temperature delta T. And then we can rewrite this. So we have the heat capacity at constant pressure, but not at constant volume. So we can replace CV by Cp minus R, and this becomes N into Cp minus R times the temperature at state B minus the temperature at state C. And again, these values are all known, so we can calculate this work done. So that's minus 3 moles, which is N, into the heat capacity at constant volume, or constant pressure rather, which is 29.1 joule per mole Kelvin for this gas. Minus, well, we have to subtract the gas constant R, that's minus 8.3145, which has to have the same units, joule per mole Kelvin, times the change in temperature, TB minus TC, which is 600 Kelvin minus 492 Kelvin. And so calculating, we get the work WCB to be minus 6.735 times 10 to the 3 joules. Now finally, part BA has constant volume. Now for constant volume, we know there's no boundary work done. So the work done in this process is 0. And hence we can calculate the total work done since we have the work for each cycle. So the total work done in this cycle, W, is equal to WAC plus the work done from B to C, WBC, plus the work done in process BA, WBA. And we can substitute each of the individual process works. 4.789 times 10 to the 3 joules plus WBC, which is a negative, so that's minus 6.735 times 10 to the 3 joules, and WBA is 0, which gives us the total work done for this process to be minus 1.95 times 10 to the 3 joules.